Okay, folks, sorry I was a little late. I jumped into the wrong Zoom meeting on accident. But we can go ahead and get going. Danny and Sally, I see, jumped onto this one, had questions about var, const, and let, which is a discussion I've had with several people. So I added a link in here in the agenda notes for this office hours to a post that pretty well summarizes my feeling on like when to use var, const, and let. And the short version of that is don't use var and just use const and let, and use const when you have no intention of reassigning a variable, and use let if you do. But I think it'll make more sense if I pull up some code to that effect. So I'm going to do that now. I'm going to share my screen. Okay, so let's look at some code. And actually, here we go. Okay, so here's an example. We got a file here with a function in it that takes an array of numbers and counts how many of them are big. So here is a situation where I'm using let because later in this file, I'm going to start with let being 0, but then I'm going to change it. I'm going to assign it different integers as we loop through this array of numbers. And every time we find them one that's bigger than 100, I'm going to increment that counter. So this type of thing is one of the few situations in JavaScript where you're actually reassigning the value of a variable. At first we said count is pointing at this value, but then we're changing it. We're saying, no, count points to 2, count points to 3. And so you can see how this works. We pass in an array of numbers to this function, and we're going to get this count out. And I'm going to run it here just so we have an example of it working. So it finds the 3 big numbers. And you'll notice that I also have some constants down here. So this numbers array is always going to hold this array of numbers. I'm not going to change it. So I use const there. And that's sort of a signal to me that, and to other developers coming in later, that this numbers thing is always going to hold this array. Hang on just a second. Someone's saying that the Zoom link is not working. So I'm just going to post a, let's see, how do I do that? Hang on just one second. Let me make sure they've got the right link in there. Calendar, this thing, this thing. Huh. No one can get into my Zoom link. Hang on a second. It looks like there's only one person in here. Oh. Okay, can the 3 of you that are in here hear me? Is it working good for y'all?
Yes.
Did you just click on the link in the Slack channel or in the Google Calendar invite?
In the calendar. No, in the agenda.
In the agenda, okay. Yeah, it should be the same. Should be the same link. 764155849 and 764155849. Okay. Don't know what to tell people. Weird. All right, well, I'm not sure what to do about that. The link, that is the link. It's the link that I clicked on. Let me just make sure it is the same. Yeah, it's the same link. All right, that's unfortunate. Hopefully it'll work itself out. What was I going to say? Okay, so I've got this other count variable down here. So notice I've got count in here twice. I've got it in the function, and I've got another one out here. This is a different variable because this one's obviously, well, maybe not so obviously, this one is scoped to this function. So when I say let count in here, I mean inside this function, count is going to hold this value. And then when I reference it on line 6, I'm referencing the count that's defined in this function. And then outside of this function, I'm declaring a different variable called count. And this one I'm saying is a const because I'm not going to reassign it. It's just the result from this count big, and I just use it on the next line, right? So those are a couple of like good ways to use let and const. The thing about var is that var, the reason I say don't use var is because var behaves counterintuitively. It doesn't behave the way that variable assignment behaves in most other programming languages, and it doesn't behave the way that you would sort of expect it to logically. And that can have some surprising and error-producing side effects if you're not careful. So for instance, if I changed this to var, well, so, okay, so var, the thing about var is that var is when you declare a variable using var, a couple of things happen. One is that var has function scope, which means that if it's inside a function, then it's defined within that function. So in this case, var here would act pretty much the same as let in that case, right? It's defined in this function. It's going to be visible in that function. There's a different var that happens out here. What gets funky is when you start declaring var outside of a function. So if I say that this var count equals big numbers, at this point, this var count is a global variable. And it's a global variable that exists not just after it's declared, but it also exists before it's declared. So even though it's only declared here on line 14, what JavaScript does is it basically rewrites this and it sticks a var count at the very top of my file and makes this just an assignment. So this, what we're seeing here, where count is declared at the very top of the file and then used on line 15, is exactly the way the JavaScript interpreter reads this code here. Even though I'm declaring it down here, JavaScript is hoisting that variable. It's basically saying, okay, I'm going to declare it at the beginning of the file, so it's always available. And what that means is that inside this function, if I don't redeclare var there, this will still work. Excuse me. This will still work, but now it's when I say count equals 0 here, it's actually this count that's getting assigned. And we can prove that by just not even doing this assignment at all down here. So if I just say var count here, And instead of assigning the return value to it, I just declare it here and then call count big and then print out count down here. Turns out that this function, which was declared before any of this variable was even instantiated, before we declared the variable, is like operating on that variable. It just gets very weird. It gets very weird very fast. So let and count just have like saner semantics to them, that they don't exist until you define them like lexically in the code. And they also have block scope, which means that if I declare a, let's do another example here. Go back to the saner version of this. All right, let's do another example. So let and const, the other difference between them and var is that they have block scope instead of function scope. So let's say that I have some function and I'm going to say let let a equal 1. I'm going to say if, let's do this, if true, let a equal 2. And then I'm going to log a here, and then log a here after the block. And then call foo down here. So if we run that, we'll see that a here, when I print out a here, it's 2. But then when I print it out here after the if block, it is 1 again. And that's because the let variables are block scoped, which means if you declare a variable inside a block, basically inside curly braces, either in like an if or a for or a while loop, then it's defined and it exists within that block from the point that it's declared to the end of the block. And then after the block, it goes out of scope and it's basically not in effect anymore, which returns you to the outer scope, which is the function in this case, where we have another let defined with a being set to 1. In general, I would say this is a bad idea just in terms of code readability, to have like multiple variables in the same function that are serving different purposes but have the same name. Like that's going to get confusing. But there is some value in having variables like scoped in the block they're in, so that they're not sort of bleeding outside of the block, if that makes sense. If I declare a variable inside a block like this, then it shouldn't be used or affect anything outside of that block. And using let sort of enforces that best practice, that your variables sort of stay contained in whatever block that they were defined in.
So Trevor, are you saying that if I use let or const, it's not actually accessible on, say, line 25 if I use it in line 22?
Right, yeah. So say if I make this b, if you try and console log b here, you should get, if I go back to the right directory, you should get an error. Yeah, so we're getting a reference error, b is not defined. And that's happening on line 25 because we're trying to reference b outside of the block that it was defined in. So it is more restrictive, and it's more restrictive on purpose. The idea being that as I'm coming through and reading this code, when I see if true, let b, I see that you're defining this variable here, and then as soon as this block ends, I can remove that variable from my mind. I don't have to worry about it anymore because I know that it's not going to affect anything or be used outside of this block. And that just, it makes the code easier to read. It keeps things like more contained closely. And so if I have a variable that I want to use both inside the block and then out later on, then I'll declare it further on up, like I had declared this a, sort of stating my intention implicitly that like, this is a variable that's going to get used, you know, that has the scope of this whole function. Does that make sense? Any questions on that?
So I was I was going to ask, like, if you're assigning a function to a variable, whether it makes sense to use let or const, because like you're not really going to like reassign a function. But then I kind of have a secondary question, like if you should just always use var in that situation, because I know a lot of things kind of rely on the function. Like some things I've been reading are like, yeah, make your functions at the bottom, and then you can call them above because of hoisting. So if you're assigning a function to a variable, what should you use?
Gotcha. So if you're assigning a function to a variable, I would say use var or const. So you're right that const makes sense just because you're not reassigning that function. You're not going to reassign that variable like something else. It's going to always be that function. The thing about hoisting, and that is a good wrinkle, that because of the hoisting, it allows you to declare functions, but then you use them in the file before they're declared. And the way that gets helpful is this. So let's say we had, actually, instead of deleting all that, just in case we need it again, I'm just gonna go down to the bottom and do some more. So this is something you'll see a lot, and it's a bit of a preference thing. So let's say that I've got, var, so I'm gonna create some function that is going to, make everyone happy. And we pass in all the people. Sorry, this is a function. Right. So we have a make everyone happy function. And then this is going to do a couple of things, right? So it's going to, first it's going to, people. So I'm going to give everyone lots of money. Make people safe. I don't know. We're going to do a couple things to make everyone happy. So we have this like really complicated function that's doing a lot of things, right? Let's see, we should probably solve world hunger. And then later on, we're going to define those functions, right? Give people lots of money is some function, and we're going to have solve world hunger is some function, and make people safe. So using var in this case, the hoisting is really helpful because what it means is that I can define this make everyone happy function and just reference functions I haven't declared yet in the file, and then build those functions later on. And I do like this style of programming where you use functions before they're defined, because it's easier to read through if you come into it for the first time, because you're reading the like higher level functions first, and you're saying, oh, okay, this big function in this module is this make everyone happy function. And I can see that it gives people money and it makes people safe and it solves world hunger. And then as I go down, I could say, oh gosh, I wonder how it's solving world hunger. And then that's further down, right? And it sort of reads more like a story. You're sort of introduced to these functions when you see them used, and then they're defined later on. It can feel a little bit backwards if you have to do this backwards. And like you end up having a lot of small little helper functions at the top of your file that aren't super useful. And then like the really interesting stuff your module is doing tends to be down at the bottom once you've defined all the helpers and can actually use them. So var is nice for hoisting in that sense. And if we used const here for these, this wouldn't work, right? Because now these consts get defined down here, and give people lots of money isn't defined up here yet. So that is true. However, what I would do instead of like creating vars and assigning functions to them is just define the functions using the function declaration syntax. And just do it this way, right? Functions can be given a name, and by default, the hoisting happens on functions when you declare them like this. So let's see, solve world hunger. Forget which ones I've defined and which ones I haven't. Solve world hunger, make people safe. What's the other one? So for my money, I'd rather see this, where you just declare functions this way, and then you get that hoisting behavior in the functions, and then you just use let and consts when actually declaring variables. JavaScript allows you to like define a function and then assign it to a variable, but in a lot of cases, you don't really need to do that. You can just use this like function syntax, which is a little bit cleaner, in my opinion, than having like a variable declaration and then an assignment and then an anonymous function. Like just name the function when you declare it and you don't have to do the variable assignment. That's my 2 cents. Does that make sense?
Yeah.
Other questions on var, let, and const? I'm gonna try and find the chat if I can. There it is. Ooh, lots of stuff in the chat. Functional dependency is gone. Yeah, so let does not hoist. And yeah, this is the thing about you might need the variable, the function to be hoisted. But if you just don't assign the variable to, don't assign a function to a variable and just name it, you sort of get that for free. Is there a reason to define a function and assign it to a variable? There is. There are reasons to do that, but usually I wouldn't do that just out here like in the global scope of a module. Usually if I'm like assigning a function to a variable, I'm doing it inside a function because I'm like declaring a callback or something like that. So it's a case where I'm creating a function and I don't want it to be like scoped to the whole file and available to the whole file. It's some sort of like small helper function that I'm using within another function to probably pass in as a callback or something like that. But usually in those cases, I'm not going to need the hoisting behavior. I'm declaring it before I'm using it. It tends to be how I approach that. The thing about var is that JavaScript used to only have var. It was all there was. It was the only game in town. And then you could also do things like don't even use var and just start referencing variables without any sort of var letter const before it. And let and const are sort of come in as a way to give JavaScript something that like other languages have had for a long time and sort of replace the sort of very vague use of var with things that are a little bit more specific and expressive and have like better constraints around them. So I'm sure you will find people with different opinions, but that's where I'm coming from. And I did link to an article in the office hours agenda document that kind of goes into a little bit more detail about like, I don't know, it's an opinion that I agree with and it's kind of well put there. So you might read that if you still have questions or are curious. The last thing I'll say about this, just before I move on, is that there are actually very few cases where you need to use let. So this is the only one that I can really think of where you're like incrementing a counter that you need to have a variable and then keep reassigning new things to it. Something you might feel like you need to do is use let if you have some array that you're pushing onto. So say we wanted to like group up all the numbers, and so okay, we're gonna take that num and we're gonna say some array and then push the variable onto some array and then return the return the array. So in this case, it looks like you need to use let here because you are modifying the array, but you don't. You're not assigning a new array to some array. You're not making some array, this variable, point to a new object. It's always pointing to the same array. It's just that the array that it's pointing to is getting bigger. And that's fine. You can still use const here. The only thing you can't do once you use const is type sum array equals. This is the thing that will get you in trouble. If you try and say sum array equals anything else, you will get in trouble using const. But if you're not going to do an equals assignment, const is fine. And you can modify the value that's being pointed to. You can add keys to an object or add elements to an array or you know, that type of thing. You just can't like reassign it.
So my first two comments in the chat both point to situations where it's, I believe, you have to use let instead of const. And I'm wondering if you think those are.
Yeah, there's some complexity. It seems that nice. You need let in a for loop. Yeah, so for loop is a good example of a place where you need to use let because you are reassigning that variable in a for loop. And the other is you need to declare a constant before you assign it because you're writing a function that will depend on it before you assign it. You can't use const. Yeah, and that's what we were talking about the function hoisting. And I would say, yeah, you can use var in that case to like assign a function to a var, or you can just not assign a function to a variable at all and just name the function like we did down here. And this will give you that hoisting behavior without actually having used var at all or any like variable assignment. And for loops is a case where you would need to use a let, but with where JavaScript is right now, there aren't a whole lot of cases where you need to write those sort of C style for loops where you're saying for let I equals 0, I is less than 10, I plus plus. So this type of for loop, I've been working here a year. I've never written one of these. It's just so rare that you need it. Almost every time you're doing something like this, it's because you're looping through an array of some kind. And in that case, the sort of array for each behavior is usually a lot easier to read and follow, where you just like have an array for each and then you've got some anonymous function. And if you really want to, you've got your element. And you can even get the I in that callback if you want. So I tend to prefer this method anyway, which is another reason I probably don't end up using let as often because I'm not writing for loops that way. The thing about these kind of for loops is that like it's just really easy to get off by one errors in here that you're like, wait, is it less than 10 or less than and equal to the length of the array? And so if you're looping through an array for each, just kind of takes some of the thought out of it for you. So there aren't a lot of cases where I find I actually need a for loop that's like this type of for loop. But if you need one, you need to use let there. Const will give you massive errors. Questions in the chat. Cool. Other questions about that? Does that cover the questions people had about var for let?
Well, there was my point about a for of loop.
A for of loop. What's your point about a for of loop?
The documentation says you can use const there, even though it sort of intuitively seems that you're reassigning it, but you're not assigning it.
I was not aware of that.
In each iteration, you're not assigning it, but it seems to resemble a for loop. But
oh, right, because it's like assigned in the block. Yeah, that's interesting. Yeah, I can see that. It kind of makes sense. Yeah.
But you would recommend using let instead of const in a for in?
In a for in, I mean, no, if const will work, use const. I think that makes sense. Yeah. My preference is sort of like, if you don't need let, because you're not actually doing another assignment, you're not doing anything that const would prevent you from doing, then use const. Otherwise, you're sort of signaling to a future developer, like, this variable needs to be just let, because I might be overriding it. I'm going to be overriding it somewhere else. And that can end up be confusing if that's not actually your intent. So the idea is like, use the one that best expresses your intent. So using let when you don't actually intend to overwrite the variable can sort of confuse a programmer coming in later on. Like, maybe I don't understand this because I don't see where it's being overwritten again, or that sort of thing. And it'll also help you catch bugs that if you accidentally, if you're not thinking and you do something that overwrites it when you didn't mean to, you'll get a nice error from Node when you try and run your code.
Is it true that there's no way to retroactively constify a variable, sort of like freeze?
Yeah, that's, as far as I know, there's not. Yeah. Okay, so we got a question here about try catch error syntax. Is it just, do you want me to just sort of generally like talk about how that works, or do you have specific questions about it?
I just generally how it works. Like, I've like used it in, copy paste style, but every time I see it, I feel like I don't know how to use it.
Yeah, let's throw some errors. Love this stuff. Okay, so just gonna delete all the things. So let's say we have some function that's gonna what's a good example? This is gonna reverse a sentence. Oh, let's not make this too complicated, sorry. Okay, because I can't think of a better example, we're just gonna use a fake function that we don't know what it does. But so we have this function, and let's say that this function calls something else that might break, right? So a good example of this is well, let's call this a pretty adder, right? So this is going to take two numbers, ooh, even better. I'm going to make this calculator, and it's going to take a couple of numbers and then an operator. This will work. Okay. So, and then we're going to say if operator is plus sign, then we're going to call this add method with num1, num2. Okay. And then we can make add, and it's going to take num1, num2, and it's just going to add them together using this really super secret addition notation. Okay, so we got these two functions, and one calls the other, and then down here we can do things like add to plus 2. And here, why don't we make an else to handle this error condition, right? That else, if someone's asking us to use an operator that we don't know about, we can say log operator not supported. And then show them the operator that they're trying to use. Okay, so let's look at a couple examples here. Just trying to motivate, let's say 4 minus 2, trying to motivate why we'd even need a try-catch situation. So if we run this, so we should be returning this. Return add. There we go. Okay, so this is the difference. Long sum. This is going somewhere, I promise. Thank you for your patience while I type. Okay, so now if we run this sucker, okay, so we're trying to do some error handling here, right? And we've got a couple of problems. One is I've got this, I'm catching this error condition that like, oh, you gave me an operator I don't recognize, I'll just log an error, right? But what ends up happening is that I log that error, but then diff here still comes out undefined. So the first one, sum, works great, right? We get the sum, get the diff. Diff ends up being undefined because it didn't know how to subtract. Then we log sum, we see that here, and then we log diff, and diff is undefined. And we got this operator not supported error when we ran calc the second time. So there's some weird stuff going on here where the error gets printed out, but then I still end up having to notice that diff is undefined, and because I don't want to see this diff printed out, right? I want the error to just be just the error message, right? So I could do something like this and say, okay, well, if diff let's see, if type of diff equals or is not undefined. So that works. But the problem with this code is that I'm now I've got error handling code in two places for the same error. I'm sort of handling it here, and then I'm handling it down here. And as far as this calc method goes, it makes this calc method a little bit harder to work with, that instead of just saying, well, it'll always return the result of the calculation, I have to say, well, it'll return the result of the calculation unless there's an error, in which case it's going to print out the error, and then it's going to return undefined. So make sure you check that it's undefined before printing it out. And I got to do a lot of this stuff every time I use result from calc after one of these big, ugly if type of result not equal undefined. So this type of error handling code can sort of get messy.
So what's the downside of returning the message instead of making it the argument of a console log statement?
So the downside of that is that it's not much better than returning undefined, and it's actually a little bit worse. So if I return undefined, undefined is at least false. So I could simplify my if statements to this, just like if I got something, return it. But that starts to break down if I'm returning a string that represents an error message. The other problem with returning a string to represent an error is that this calc method returns numbers, so it works in this case. But imagine if this calc method wasn't doing arithmetic calculations. What if it was manipulating strings and was concatenating two strings together or uppercasing a string? Then it's really hard to test the result and figure out, is this the string that's the result of my operation, or is this a string that's telling me about an error that just happened? So in general, having to check the return value of a function to determine whether it indicates an error or not just gets really, it gets really tricky really fast. And that's where throwing errors come in. Throwing errors sort of gives you another way to send a signal back to the caller of a function that something went wrong. And it ends up making the code a little bit cleaner. So instead of this console log or return, I could throw an error. And the way you do this is you create an error object, new error, and you pass in a string. for simplicity, I'm just going to make the string operator not supported. So this here, new error, creates an error object. And then I pass that error object to this throw keyword. This would be, I could also do this. So create the error object and then throw it. In practice, though, you'll always see these things together. Just throw new error, operator not supported. You almost always see it that way. So in that case, I can get rid of this if checking, and I can go back to my original code. And when I run that, I get this error, operator not supported. So when I threw that error, it bubbled all the way up. And it, if we look at this whole output here, tells me the line that the error happened on, line 5. It shows me the line where the error was thrown, and it gives me the printout of the error. So that's nice, right? I don't get that situation where there's an error, but then later on I'm printing this undefined value. It sort of stops execution as soon as the error happens. Nothing else that happens after that in this function will run. The function returns immediately, and then the function above that will return immediately. And it kind of pops all the way back up off the stack, shuts down the program immediately, and prints out that error message. So that's nice, but my sum never got printed out, and there wasn't any problem calculating the sum. So I'd kind of like that to happen, right? So that's where try catch comes in. So try catch is a way to catch errors that get thrown so they don't shut down your whole application. So throw is sort of the way to like return an error value, and try catch is a way to catch it, to then do something about it programmatically instead of letting it halt your whole program. And so the way that would look is we could just wrap both this sum, both of these methods, right? We so we know that either of these things could cause problems. And now we're getting into territory where we actually need to use let. After I said you rarely need it, this is another case, right? Try catch, there's this block. So if we use const in the block, then those things are scoped to the block. So we're gonna wanna say let diff. And then here we can log the error. Or we can do something. We can do something here. Do something here. So everything that happens inside a try block, if any of these functions that get called inside the try block throw an error, then instead of your program terminating, this catch block of code will get executed, and then your program will continue as normal. So actually, we could do this. Put these console logs in there, and then let's see what that looks like. So we ran the diff calculation, we hit an error, and so the error was thrown, but we caught it. So instead of getting this big error message that we got the last time, we don't get that at all, we just get a message. So, one thing we can do here then is, maybe we can just give a friendlier message saying, an error occurred, please try again here. So you'll see try catch a lot for this, where you're doing things that could have errors for a lot of weird technical reasons, and you just want to have a catch-all that says, okay, if anything went wrong in this summing calculation, then just print a nice message to the user. And another thing you could do here is you could then send, you could have some error handling code that takes that technical error and emails it to the developers and say, hey, we got some weird error in the process of running this application. We just told the user that there was an error and like not to worry about it. But then we send the actual error object with all of this information about like where it was thrown and why and all those things to the developer to look at to figure out like why that happened in production.
Did you need to declare sum and diff before the block in which they are assigned to?
I did not the way it's written now. Since the console logs are in the try block now, that is no longer necessary. You're right.
If you didn't throw an error in your function with the catch, like no, is that the error you've thrown, is that's like what default gets past the catch, or like what's that ERR?
Yes. You define catch, and it's kind of like a function where you declare, so I could name this anything, but it's going to be whatever error was thrown will get assigned to this variable here, whatever I end up calling it. That makes sense? And by convention, you will almost always see this ERR as an error, as the name of a variable to hold an error in a catch block. In fact, I was typing it this way when I started here, and SJ kept coming back and just deleting the last two characters, just to make things consistent. But you'll see this ERR as like the name of the error variable almost universally in JavaScript. So it's just kind of a convention, but it could be anything. So go ahead.
If you don't throw an error, will it just like take some JavaScript error and put it in there? Or do you have to throw the error?
Right. You mean if an error is not thrown at all?
Yeah, like if you didn't throw an error, but it just didn't work, like if something else broke, I don't know. Gotcha.
So yeah, there are two ways an error can get thrown, or at least two. One is you can explicitly throw an error. The other way, and this is what I was getting to. So let's say that let's do this. Let's define subtraction so that error stops getting thrown. And just for simplicity's sake, I'm going to say number 1 minus number 2. And if I can type correctly, why do you hate me? There it is. Okay, so if the error is not thrown at all, then the catch block just never gets executed. But there are other ways we can throw errors, or the errors can pop up. And errors can pop up also just because like built-in JavaScript functions or operators encounter a problem. So one example of that might be, what if we implemented division? Actually, even better. If we erroneously pass in strings instead of numbers here. So now when we get to this line here, we're going to be trying to subtract 2 strings. And we should get some kind of an error in JavaScript. No, make it converted. Sorry. Probably better to do this. So if we just pass undefined as the second number and we try and subtract undefined from 4, we're going to get not a number. Man, JavaScript, you're going to be like that? Surely there's something we can do to cause an error. No, it's just really happy to do that for me.
What if you like use a variable that's like, what if you like got the wrong variable name or something? If you accidentally typo.
That's a great example. Right, so if we just made this num3, I think, so now we're getting, take that away. There we go. Yeah, so that error still bubbles up. right? And we don't see it because we're catching it and logging out something else. But if we actually log out the error, then we'll see that we're getting this reference error, num3. So reference error is a type of error that like Node, the JavaScript interpreter, will throw for you. There's a lot of different things like that. Divide by 0 is another one, I think. I can't remember if that's going to return not a number or if it's going to actually throw an error. But yeah, other runtime errors like that will come up. So it's worth talking about why try catch versus like returning an error value. We talked about that a little bit, but one of the reasons is that if you have a function that just returns some sort of signal that something's gone wrong, like returns a 0 or an undefined, you end up in situations where I have this, and then I'm gonna like pass that to another deal. So in this case, it's very common to write code like this. It's easy to forget to handle errors, right? You're calling a function, you're not thinking like, what happens if someone tries to divide by 0, or if they try and pass in a monkey when I'm expecting an integer, or whatever. So especially when you're just trying to get things to work, right? Your code's working, your tests are passing, you move on. You don't think about all the possible error cases. And if you return, if a function like thing that might fail just returns 0 or undefined when there's an error, it's easy to not catch it. And then what happens in your live production code base when the thing's running on the website and 8 million people are buying, you know, furry unicorn dolls from you, is this method fails and result gets set to undefined, and then you pass result on to the next thing. And then you have to ask yourself, what exactly is the behavior of foo if result is not the expected result, but is just an undefined value? And that's usually kind of undefined. Like, I don't know, how is the rest of the result just is undefined? That case was never considered. And what happens a lot of times is that the code actually works better than you expect it to. And that's the problem. If foo just immediately fell over and threw some other error and your program crashed, that would be fine. The dangerous thing is when foo takes undefined and then goes and starts trying to record purchases in the database with it, right? And if those purchases fail to get recorded, that's great. But if for some reason they don't fail, they just get recorded in some sort of a corrupted state. And now you've got like purchase history that's all out of order. And like the amount of damage that this one error can do gets a lot broader, and it can get a lot harder to track. If your program crashes, your customers call you and say, the program crashed, what's going on? Like, you notice it and you can go in and fix it. But if it just introduces some subtle error to your like purchase history, then you may not notice it, but you're slowly losing money, or your customers are getting charged a little bit more than they're supposed to being charged. And you find out 6 months later when it's $1 million problem, right? So the nice thing about throwing errors in try catch is that if thing that might fail throws an error and I forget to wrap it in a try catch block, I forget to explicitly handle the error, at least the program will fail and no other damage will be done, right? The program will just quit and say, hey, developer, you never thought this might happen and it did, and so I'm just gonna give up. I'm not gonna try and be heroic and guess what you might want to do. I'm just gonna shut it all down, as opposed to like passing some error value through the system to other functions and letting it like possibly cause other problems further on down the line. Does that make sense?
Yeah, this was really good. Thank you.
Cool. All right. Any other questions in the minutes remaining? Anyone at all? All right. Well, thanks for showing up. I hope that was helpful. don't forget to add stuff to the agenda going forward. If you think of things, even if you think of things through the week and you just want to remember like, oh, I'd like to see that at some point, like feel free to pull that up. It's pinned in the phase 2 channel and add stuff there. And yeah, happy coding. And I will see y'all on the internet.